So water is one of the most important molecule for an organism, right? Or individual, for life, period, right? Water contains certain types of properties. These properties are important, that give water its important value for life, right? And so first, we know that water is polar, right? Water has a slight positive end and slight negative end, right? And this allows for hydrogen bonds to form between other water molecules and other polar molecules. Think of the monkeys in the barrel game, where you have these plastic monkeys and you try to link their arms and see how many you can link together. That's how these hydrogen bonds work. Each would be a water molecule, and they hook together to form these long chains or mats of polar molecules. Water has a high cohesiveness. All right, cohesiveness cohesion is the tendency of the molecules to stick together. So they stick together very well because of these hydrogen bonds, right? And so this cohesiveness allows for a high surface tension, and that's the measure of how difficult a certain liquid is to stretch or break. All right, how difficult it is to stretch or break a certain liquid, not liquid. And so water has a high cohesiveness. It has a high surface tension. You can go to the creek or pond and you can see these little insects skating on the top of the water. That's because they're light enough that they don't break the surface tension of the water, and the surface tension's caused because it has high cohesiveness. Water for plants is down in the roots, right? You have to go down. The water has to go into the soil. The roots get the water out of the soil. So in order to photosynthesize, the plant has to have water, and the water has to be in the leaves where the photosynthesis occurs. So in order to get water from the roots to go up against gravity to get to the leaves, it has to have this high cohesive nature that allows that water to be drawn up through tubes up against gravity to get to the leaves. And again, the only reason why a plant can do this is because of the high cohesive nature. Water also has a high temperature stabilizing effect. This is where water requires high input of heat. All right, heat is the amount of energy associated with the movement of atoms or molecules within a body of matter. All right, all matter has molecules and atoms that are moving. All right, some of them are just really, really slowly moving, but that movement, the amount of energy to move those atoms and molecules is called heat. All right, then its temperature is the measure of that heat's intensity, or the average speed of the molecules. So it requires a lot of heat in order to raise the temperature of water, because it has these hydrogen bonds in there that absorb a lot of that heat energy. If you put a pot on the stove and you turn it on, and it will sit there, right, for a long period of time, depending on how much heat you're putting up on the pot. before the temperature of the water actually starts to increase until it gets to a boil, right? And so this temperature stabilizing effect is really important. If you put, now I'm not going to, you do not do this, but if you put, for instance, ethanol in a container and heated it up, the temperature increases quickly as the heat is introduced to the liquid. So this high temperature stabilizing effect is important for like our bodies, because during when we have a infection and the white blood cells are going to attack the infection, and our temperature, our heat is generated by this immune system reaction, and as this heat is given off, our core temperature doesn't increase very readily until a certain amount of heat is absorbed, and then once that happens, the core temperature starts to increase. So it's very important for things like for babies who are cells are developing in their brain. If they have a high temperature, you need to respond by cooling the not put it in cold water, but in cool water, and try to get that core temperature down, because you don't want brain cells to be killed. So high temperature stabilizing effect. And then water is a very good solvent. Solvent is a dissolving agent. So anything you put into it, if it's a solvent, it will dissolve into that solvent. And so whatever you put in that dissolves into is dissolved by a solvent is called a solute, and a solution then is the liquid that contains the homogeneous mixture of the solute and the solvent, right? So again, polar molecules, ions, are readily dissolved into water, but the things like oil that are nonpolar do not dissolve well, right? So if you put sugar and water being your solvent, sugar, solute, red dye number 3, red dye number 2, yellow dye number 5, and artificial flavors, and you put those in as solutes and you mix them all up, you get a solution, and that solution is what? Kool-Aid, right? Kool-Aid.